Okay, in this video we're going to be looking at how to multiply and divide complex numbers in their Cartesian form. So let's start with multiplying two complex numbers together. If you want to work out what z times u is, that's simply the same as 2 take I times by 3 plus 4i. And we can simply just use our distributive law to expand out these two brackets like such. So we can say 2 times 3 is 6, and then 2 times 4i is plus 8i, and then minus 3i, and then minus 4i squared. And we can simplify this as 6 plus 5i take 4i squared. And we need to recognize here that I squared is simply the same as minus 1. So if we have I squared as minus 1, this is really just the same as minus 4 times minus 1, which is simply just equal to 4. So we get 6 plus 5i plus 4. So our final answer in Cartesian form is 10 plus 5i. That is our solution to multiplying two complex numbers together. And if we wanted to divide two complex numbers in their Cartesian form, so in this case z divided by u, we can rewrite this as 2 take I divided by 3 plus 4i. And in order to multiply, or in order to divide any two complex numbers together, you must multiply both the numerator and the denominator by the conjugate of the denominator. So we have to multiply by the conjugate of u. And if we have a complex number where in this case u equals a plus bi, then the conjugate of u is simply the same as a take bi. So the imaginary component becomes negative. If it was negative here, it becomes positive, and if it was positive here, it turns into a negative. So in this case, we're simply just going to times the top and bottom by 3 take 4i. 3 take 4i and 3 take 4i. So let us now work out what this actually equates to. So on the numerator, we can use our distributive law, like we did before. So that would be the same as 6 minus 8i plus 3i, and then plus 4i squared, all over, and on the bottom we have the difference of two squares. So what we can say is this is the same as 3 squared minus 4 squared I squared. So that would be the same as just 9 minus 16i squared, which is really just the same as 9 plus 16. So that would be 25. And on the numerator, if we can simplify this, we know that 4i squared is really just the same as minus 4. So 6 minus 4 is 2. And then minus 8i plus 3i is the same as minus 5i. So 2 minus 5i all over 25. And that would be the same as 2 over 25 minus a fifth of I. Okay, this is our next question here. If z equals to 2 take 4i, our goal is to work out these four parts to this question. So let's start with part 1. We're going to work out what is z times the conjugate of z. So in this case, what is 2 take 4i times by 2 plus 4i. So this is just the same as the difference of two squares. We can see that it's just the same as 2 squared minus 4 squared I squared. And if we evaluate this, that would give us 4 minus 16i squared. And we know that I squared is the same as negative 1. So that would mean that negative 16 times negative 1 is the same as plus 16. So 4 plus 16 is really just the same as 20. So that is the answer to part A. Question 2 says we need to work out z times z plus z bar. So this is the same as 2 take 4i times by 2 take 4i and then plus 2 plus 4i. And the reason we did 2 plus 4i is because the conjugate of z is 2 plus 4i. Let us first simplify the inside brackets of both of these. So we get 2 take 4i times by, in the inside bracket, we have 2 plus 2 is 4, and then minus 4i plus 4i, they will just cancel out. So we're left with times by 4. And if we're timesing a complex number by just an integer, we can times each of the real component and the complex imaginary component by 4. So this just becomes 8 minus 16i. That's how you do question 2. Question 3 says to work out the inverse of z. And to work out the inverse of z, that's really just the same as 1 over z. And 1 over z in this case is 1 over 2 take 4i. So to evaluate this, we can just multiply both the numerator and the denominator by the conjugate of 2 take 4i, which in this case will be 2 plus 4i. So if we do this, we get something like this. And what this evaluates to is on the numerator, 1 times 2 plus 4i is just 2 plus 4i. And on the denominator, we can use, again, the difference of 2 squared. 2 squared, sorry. So this is 2 squared minus 4 squared I squared. And we previously just worked this out as 20. So the final answer for this one is we get 1 over 10 plus 1 over 5i. And the last one is we need to work out what z over I is. Z over I in this case is really just the same as 2 take 4i divided by I. So let us just times the numerator and denominator by I to cancel out the I. So in this case what we get is we get 2i take 4i squared all over I squared. And if we wanted to expand or simplify this, on the numerator we get I squared is minus 1. So minus 4 times minus 1 is just plus 4. So 2i plus 4, or just 4 plus 2i. All over I squared, which is negative 1. So this is the same thing as negative 4 take 2i. Okay, and this is our last question here. We're going to solve each of these equations for the variable z. So let's start with the first equation. We're going to solve for z for 2 take I times z equals 42i. So if we wanted to solve this equation, we can just rearrange for z by dividing both sides by 2 take I. So we're left with 42i divided by 2 take I. And if we want to simplify two complex numbers divided by each other, we can simply times the top and bottom by the conjugate of the denominator. So we can times the numerator by 2 plus I and the denominator by 2 plus I. So now what we have is on the top, we can multiply 42i with 2 plus I, and that'll simply just give us 84i squared plus 42i squared. Sorry, there's no I squared for the first one. It should just be 84i. And then on the denominator, we can do the difference of 2 squares. That's just the same as 2 squared minus I squared. And we can start simplifying this. On the numerator, 42 times I squared is 42 times negative 1, which is just minus 42. And if you want to write it in complex form, that's just the same as minus 42 plus 84i. And on the bottom, we can see that we have 2 squared minus I squared. And 2 squared is 4, and I squared is minus 1. So this is really just the same as minusing away, or in this case, plussing 1. So we get 4 plus 1 is 5, and our final answer, if we write it as a complex number, is minus 42 over 5 plus 84 over 5i. That's the answer to question 1. Now question 2. It's very similar. Okay, so I'm going to give you a second to pause the video and try it yourself. Okay, now let's do it. For this one here, we can simply just rearrange all of these components to the other side of the equation by dividing. So we can say that z is the same as 5 plus 12i all over 2 times 4 take 7i. And it doesn't look very appetizing to have this 2 at the bottom, so I'm just going to rearrange this equation, or expand this equation for the 2 out. So I get, if I times it by 2, I get 8 minus 14i. So now to evaluate this, we can times both the numerator and the denominator by the conjugate of the denominator. So in this case, 8 plus 4i and 8 plus 14i. So now what we have on the numerator, we need to multiply these two complex numbers together. So if we were to treat this as brackets, and we use our distributive law to do FOIL, then what we get is 5 times 8 is 40, 5 times 14i. It's a little bit tricky, but you can say that 5 times 15 is just 75. So then minus 5 is the same as 70. So 40 plus 70i plus 96i. And then 12 times 14 is really just 144 plus 24. So that's the same as 168. So plus 168i squared. All over, we can do the difference of 2 squares. So in this case, it's the same as 8 squared minus 14 squared I squared. So let us now clean this up a bit. On the numerator, we can see that 70i and 76i or 96i will add to 166i. And then we can see 40 plus 180i squared. I squared is the same as minus 1 times 168 is minus 168. So if we add 40 to this, that's really just the same as minus 128. So on the numerator, we get minus 128 plus 166i all over 8 squared is 64, and then 14 squared is 196. Okay, and I squared is negative 1, that's why I'm adding these two together. So 190 plus 60 is 250, but then we add the extra 10, we get 260. So we can do this divided by 260. So let us now simplify this up. 128 divided by 260, we can first divide it by 2. So on the top we get 64 divided by 130. We can keep going. That's 32 over 65. And from what it looks like, I think this is as simple as we can get it. So 32 over 65 plus, we can do the same thing here, 166 over 6 over 260. That's the same as 83 divided by 130. And from what it looks like, this is as simple as you can get, unless I'm wrong, but I think it's as simple as you can get. So plus 83 over 130i. So that is how you solve for z in this question here. It's minus 32 over 65 plus 83 over 180i. And now we have the lucky last question. We have to solve for this equation here for z. So for this one here, we can simply rearrange by dividing both sides by 1 plus I. So we get 4z is the same as 4 divided by 1 plus I. And that means, to simplify this, we can times both the numerator and the denominator by the conjugate of 1 plus I. So now we can work this out. On the top, we get 4 take 4i. And on the bottom, we get the difference of 2 squared. So it's 1 squared take I squared. On the denominator, we can see that I squared is really just the same as negative 1. 1 squared is 1, so we minus the 2. We get this is equal to 2. So we can clean this up and say 2. And then the final answer will simply just be 2 take 2i.